All right, continuation 6 through 10 for the, this is what are they called? Exercise Set A questions for Taylor series, manipulation of series. All right, number 6. Function f is defined by this series. Let's see what's happening there. 1, 2, 3. So these are going up by 1. These are going up by powers of 3. Okay, so we're going to find the limit of that function minus 1/3 over x. Well, that looks pretty easy compared to some of the other crazy stuff we've been doing. This whole function minus 1/3 would just be 2x over 3 squared plus 3x squared. It's just, I'm just leaving off this term, right? Because we're subtracting 1/3. And there I go, getting lazy again, leaving out the limit. And we're dividing by x. And dividing by x just knocks the exponent down by 1. So that's 2 over 3 squared plus 3x over 3 cubed plus and so on and so on. And since x is approaching 0, you can see all the rest of the terms here are going to have x's in them. So all of these are going to be 0. And this is the only thing that's not 0. So that's our limit. 2 over 3 squared, 2/9. Hey, that took less than 2 minutes. Awesome. Number 7. Function f has derivatives of all orders for all real numbers with f of 0. Oh, this looks like it goes into the next page. F of 0 is 5. Let's write that down here. F of 0 is 5. All right. First derivative is -3, etc., etc. And then if g of x is equal to f of x squared, find the 4th degree Taylor polynomial for g. Okay, well we need to find the 4th degree Taylor polynomial for f first. All right? And actually we only have 3 of these, so let's go as far as we can with that. So for f, that's going to be approximately equal to, remember how to build one of these things from scratch. We start with f of 0 plus f prime times x plus f double prime times x squared over 2 factorial plus f triple prime times x cubed over 3 factorial, and that's as much as we have. Okay, now if g of x is equal to f of x squared, well, f of x squared is what you get when you plug in x squared for all the x's here. So that's 5. Let's see, say minus 3x squared. I'm plugging x squared in for all the x's. Plus, and then I'm plugging in x squared in here. X squared squared is x to the 4th over 2. And they only wanted the 4th degree polynomial. So that's it. Done. Hey, that took 2 minutes too. These are easier than the other ones. Right. Number 8. The Maclaurin series for the function f of x is this. And you could look at that. Is that some recognizable one for us? No, not particularly. But looks kind of familiar. It's got looks like it has everything and it's positive, although it's not quite the e to the x series. It looks like it's not far off from that one. Find the first 3 non-zero terms and the general term of the Maclaurin series g of x, which is x times this one. Well, if you want to take that one and multiply it by x, right, that should be easy enough. We just have to distribute the x through. I get they want the general term too. Give me a break. Alright, so that's distributing the x. I get x plus x squared over 2 factorial plus x cubed over 3 factorial plus, oh, that's it, first three. And then what's the general one? It looks like it would be x to the n over n factorial. Right? Easy enough. And now they want to give a formula for g of x for this that does not involve an infinite series. That means recognize this. Well, that looks just like the e to the x series, except it's missing the 1 plus at the very beginning. So what is this series? It's the e to the x series. So this is e to the x, but it's missing the 1. This is e to the x minus the 1 at the beginning. Hey, that's another 2 minutes. We're on a roll. Number 9. Let f be the function given by f of x equals e to the x over 2. Right, the first three non-zero terms and the general term of the series about x equals 0 for the function given by g of 0 is equal to 1/2 and g of x, oh, so they're giving this like piecewise, sorry, for x not equal to 0. So this is like a piecewise definition for this. Excuse me. So I think we better write out the first few terms of this series first. So e to the x, well, let's see if we do 1 plus and then substitute x over 2 everywhere where we would have seen an x. It's x over 2 squared over 2 factorial plus x over 2 cubed over 3 factorial. There's 4 terms. And they want the first 3 non-zero terms and general term, that should say, for this. So let's see. E to the x over 2 minus 1. So we're going to subtract the 1, and then we're going to divide the whole thing by x. So taking the x off of 1x off everything is going to give me x. Oh, sorry. First term will be, let's try that again. First term will be 1/2, right? Dividing by x. The next term will be, let's see, it's going to be x over, I've got a 2 squared on the bottom and a 2 factorial on the bottom, plus here I would have had x cubed, but I'm dividing by x, so I have x squared over 2 cubed times 3 factorial. And is that the first 3 terms? We could go one more if you want. And let's look at this term. Here's our like second term, right? If that's the 0th one. Looks like I have x to the n, and then on the bottom I have 2 to the n plus 1 times n plus 1 factorial. And if we start at 0, make sure that that works for the first term. That would be, x to the 0 would be 1, 2 to the 0 plus 1 is 2, and 0 plus 1 factorial is 1, so that would give us the 1/2. So that works. That was a little tricky. That took more than 2 minutes. And is that all they want us to do? Yep. All right, number 10. Find the first 4 terms and the general term of the Taylor series for x over 2 minus x, centered at a equals 1. So that's a little twist there, right? That means we want to, centered at a equals 1 means we want x minus 1s in there in our terms, and give its interval of convergence. And they want us to note that 2 minus x is equal to 1 minus x minus 1. That's a nice little hint there. And that x is equal to x minus 1 plus 1. I'm not really sure if we really need that piece, but let's see. So if we rewrite this, we say that x over 2 minus x using their hint here and remembering that we want to have a 1 there. X over 1 minus x minus 1. You can check the algebra real quick. Pretty easy to see that that is equal to that. Well, look, this matches up to our geometric series, right? This is first term over 1 minus r. So let's see if we can write the series. So the first term is x. The multiplier is x minus 1, right? So there's my first term plus x times x minus 1 plus x times x minus 1 squared plus excuse me. There's the first 4 terms. The general term is going to be, let's see, we have x times, if we call that the first term, then that would be x times x minus 1 to the n minus 1. And what is the interval of convergence for this? Well, the interval of convergence for a geometric series is you need the multiplier, x minus 1, to be in between negative 1 and 1, right? So adding 1 to all of those pieces, we get 0 to 2. Question. I want you to pause and think about this for a second. Do you need to check the 0 and the 2? Pause, please. Answer is no, you don't. Because for a geometric series, you do not get convergence at the endpoints. Although, now that I'm saying that, because we have an x on the top, if x is 0, that's going to make 0 plus 0 plus 0 plus 0. So maybe I take that back. So in this case, geometric series, typically the endpoints don't work because we have an x on the top. It's not just a 1 on the top. The looks like that 0 is going to work. And we are going to get convergence there, but not for the 2. Right, because that's going to give us 2 plus 2 plus 2 plus 2. And that doesn't converge. All right.